Hello class. Today we are practicing with some geometric constructions. The first type of construction that we did was to construct the angle bisector, or a line that cuts an angle into two equal parts. To construct this using a compass, we're first going to center our compass at our vertex of our angle, which is point O, and we want to then sweep an arc around point O through the arms of our angle. We can label where that arc intersects with the arms of our angle as points A and B. Next, we'll move our compass point over to one of those intersections. I'm going to start at point A, and we're going to sweep a second arc through the center of our angle. We can move our compass over to point B and sweep a third arc again through the center of the angle. There's our third arc there. Okay. We can then go ahead and label the crossover of our second and third arc as point C, and we can use our straight edge to connect point C to our point O, our vertex of our angle. Nice straight line there. Okay. Now point C to point O should be our angle bisector. So we'll say line OC is the angle bisector of what? Well, of our big angle, TOW. And why would that be? Well, the angle bisector should cut our big angle into two equal parts. So if you measure the top part of your angle and the bottom part of your angle, they should now be equal measurements. And those would be angles TOC, would be the top one, and that should be equal to angle COW. So those should be equal measurements. If we center our protractor on our vertex, we set up our 0 on our 0, we can see that the bottom half of this angle is 30, and then 1, 2, or 3 ticks. And the top half of this angle, again centered there, is 30, and then 2 ticks. So we can say that each of these is about 32 degrees. And that should make the overall angle about 64 degrees. And if we look, once we have our protractor centered up, here's 60, and then 64 is right there. So that does all make sense. We've drawn a line using our compass that cuts this angle into two equal parts, 32 degrees each. In order to construct a perpendicular bisector of a line, we first off want to start with our compass, and we want to take our compass and put the point on one end of the line. In this case, I'll put it on end H. And we want to just make sure our pencil is clearly beyond halfway of the line. From here, we want to draw an arc above and below the line. So sweep out a nice arc. Next, we're going to take our compass, and without changing the size of it, we're going to move the point over to the other end of the line, in this case, point I. And then we're going to sweep out a second arc above and below the line. This should create two intersection points. We'll call these intersection points D and E, above and below the line. And those intersection points should be equal distances above and below, and left and right on the line. We can therefore use our straight edge to connect points D and E, our two intersection points there, with a nice straight line. And this should be our perpendicular bisector. We'll label where that crosses point C. So let's go ahead and write out that our line DE is the perpendicular bisector of line HI. And why is that? Because what? Well, the term perpendicular bisector means two things. The perpendicular part is that our line DE should cross HI at a 90 degree or perpendicular angle. And when we put our protractor on with our crosshairs centered at that intersection and our 0 lined up with HI, we should see that the line we have just drawn lines up with 90 degrees. So the perpendicular part is true. You can either say something like angle HCD, so this angle here is 90 degrees, or you could also say because HI is perpendicular to DE. Now that would be fine if it was just perpendicular, but we want it to be a perpendicular bisector. And in order for it to be a perpendicular bisector, the bisect part means that we need to cut HI into 2 equal parts. So you can now take your ruler and you can measure from H to C. In my case, H to C looks to be about 28 millimeters, which is 2.8 centimeters. And we should have the same distance on the other side of this line. So again, measuring, I get about 28 millimeters there, or 2.8 centimeters on that side as well. So we can say it's perpendicular because we have that 90 degree angle, and it bisects because line HC, the sort of left half of that line, is equal in length to line CI, the right half of the line. So that's constructing an angle bisector and a perpendicular bisector. The other skill that we can do is we can draw a parallel line to any given line that we have. And again, we're going to use a compass for this. In order to start drawing a parallel line, you need to first construct the perpendicular bisector of that line. So with line ME, I'm going to start by putting my compass point on E, my pencil clearly across middle. I'm going to sweep out an arc above and below line ME. I'm going to use the same sized arc centered over at M, and I'm going to sweep out a second arc like so. And again, I can connect those 2 intersection points with a straight line to construct my perpendicular bisector. And I'll label again D, and this one's already E, so I'll call this one X. Okay. Next thing I'm going to do is I'm going to resize my compass. So I want my compass to go between point C, that middle center point, and point D. So if I put my point on point C, I'm going to resize my compass until my pencil perfectly touches point D. From there, I can sweep out a third arc. So I'll do that now, like that, through point D. Okay. Now I'm going to move my point over to point D and place my pencil on point C. And I can sweep out a fourth arc, like so. So now I've got my 4 arcs. The original 2 from making my perpendicular bisector, and then these third and fourth ones that we made centered at D and C, respectively. Where those lines cross should be equal distances from the perp bisector. And so we're going to go ahead and we're going to connect those 2 intersection points like so, a straight line. I'm going to call those intersection points point F and point G. And what we should be able to say is that line FG is parallel to line ME. We can check that in a couple of ways. If they're parallel, they should be at the same angle as each other. So ME is obviously 90 degrees to my perpendicular bisector line, DX, that I made. And my parallel line here, which is FG, is also at 90 degrees to that line. Oops, like that. Okay, so they do form that same 90-degree angle, and so my two lines, FG and ME, are in fact going at the same angle as each other. The other thing we can do is we can measure the distance between the lines. It's about 1.4 centimeters at this end, and again, it's about 1.4 centimeters at that end. So it is remaining the same distance between the two lines. That distance is remaining the same. And that's our other definition of parallel. So I hope this has helped you with knowing how to do your different geometric constructions and write your concluding statements.